Okay, the last topic for section 4.3 for the test is calculate the average atomic mass. The question from students most often is why do we have 20.2 or 10.2 neutrons? You cannot have a 0.2 neutron. And so the reason for that, the answer to that question is all the masses listed on the periodic table are average atomic masses. Now, when we say average, it's not that we find 4 isotopes of chlorine in nature and we just add them all up and divide by 4. Because every element that you find in nature will have different forms, isotope forms. So the answer is that it is a weighted average. A weighted average is including the abundance or the percent of the part into the average. For example, when I calculate your grades for this class, I do not calculate your daily and your test average and add them up and divide by 2. It's a weighted average. The test is 70%, the daily is 30%, so I take 0.7, that's 70% as a decimal, times your test average, and then I add it to taking 0.3, which is 30% of your grade, 0.3 times your daily average, and we add them together. And so that's a weighted average. So if you had 86 test and 98 average of daily, what we would do, since this is 70% and this 98 is 30%, we would take 0.70 multiplied times 86 plus 0.30 multiplied by 98. That is the weighted average, including the amount of weighted percent of each into your average. So let's apply this. How do we get all these numbers? You know, this is the natural percent abundance. Okay, that's the percents. This is the average masses. So in carbon in nature, pretty much we find carbon 12 and carbon 13 isotopes. When we calculate the weighted average, we get the average 12.011, and that's what's listed on the periodic table. Same thing for oxygen. So you must be able to calculate. You must be able to calculate the average atomic mass. So in this question here, we have lithium. 7.42% of the time, we find lithium 6.015. 92.58% of the time, we find lithium 7.016. So the average mass equals to the mass of isotope A times its decimal abundance plus the mass of B times its decimal abundance plus, etc., 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 ever how many isotopes that you have. So filling that in, we would say the average here is going to be the mass of A, which is 6.015. That's the mass of the first isotope listed, times 7.42 as a decimal. Now it is 7.42% as a decimal. You move the decimal place 2 times to the left, or you divide by 100. When dividing, because percent is 100, when you divide 7.42 by 100, it becomes point. So we're going to multiply this by 0.0742. Move the decimal 2 places to the left. Plus the mass of isotope B was 7.016, and we multiply it by the percent as a decimal. Move the decimal 2 places to the left, or divide by 100, it would be 0.9258. Okay, so calculating this in our calculators. Okay, we would take 6.015 times 0.0742. That's that percent, and we're going to add that to parentheses 7.016, the mass of the second one, times 0.9258. we get the average mass of 6. How many sig figs? Got 3. 3 is my least number. Sig figs would be 6.94. So the average mass would be 6.94 AMU. Calculating the average atomic mass by taking the mass of the first isotope times its decimal abundance, change percent to a decimal, and add it to all the other isotopes.